Hello everyone, I'm Man Tianli from ByteDance Intelligent Creation Team. Today, I'm honored to present our paper titled HyperLoRA Parameter Efficient Adaptive Generation for Portrait Synthesis. Let's start with the motivation behind our work. Personalized portrait synthesis has extensive applications in the social entertainment domain. Currently, many commercial products have integrated this feature, such as TikTok, Epic, and Miaoya Camera. Existing personalized portrait synthesis methods can be classified into two categories. One is tuning-based, such as Dream Boost and LoRA. The other is tuning-free, such as IP adapter, Instant ID, and Pulled. The tuning-based methods can always produce photorealistic images, but rely on a time-consuming fine-tuning. In contrast, the tuning-free methods usually introduce an extra cross-attention module to inject identity information without online fine-tuning. However, the generated images suffer from oversaturation, lack of naturalness, and details. The manner that LoRA inject ID can usually produce more realistic results, and Hyper Dream Boost advances the development of portrait LoRA, but its zero-shot results are not good enough, thus still requires some fine-tuning steps. Consequently, existing research has not yet proposed a LoRA-based method that enables zero-shot generation. Next, I will highlight the main contributions of our work. Overall, we grant LoRA the zero-shot capability for portrait synthesis, and in detail, we propose the first zero-shot portrait synthesis method based on LoRA, which is trained in an end-to-end manner. We introduce a well-designed model architecture and training scheme to facilitate efficient training and ID decoupling. Our method can produce highly photorealistic and detailed images while ensuring fidelity, editability, and inference speed. This figure illustrates the overview of our method, namely HyperLoRA. We decompose the HyperLoRA into a ID LoRA and a base LoRA. The ID LoRA is designed to learn facial identity, while the base LoRA is expected to fit others, such as layout, clothing, and hairstyle. We implement HyperLoRA on SDXL and fix the weights of the pre-trained SDXL base model and encoders, allowing only HyperLoRA modules updated. At the inference stage, the ID LoRA is integrated into SDXL to generate personalized images, while the base LoRA is optional. Decomposing HyperLoRA into two parts has the following benefits. First, it prevents irrelevant features leaking to ID LoRA and make ID LoRA focus on the identity. Second, it mitigates the impact of training data on image quality, since the bad quality is also fitted into base LoRA, and the quality of images generated by ID LoRA is close to the base model. Then, let me introduce more details about our method. The number of parameters in LoRA is typically large, making it difficult to generate the LoRA weights directly. To make HyperLoRA training feasible, we represent a LoRA matrix M with a linear combination of k equals 128 dim LoRA bases, and leverage perceiver resampler to predict the coefficients alpha and beta. The perceiver resampler consists of several transformer blocks. In each block, cross-attention is used to interact with the feature tokens from clip VIT and face encoder. We propose a three-stage training scheme to train HyperLoRA. The first stage is to train the base LoRA. We blur the facial region of the original input image before feeding it into the clip VIT, and bypass the antelope V2 face encoder branch, making base LoRA to learn ID irrelevant features. The second stage is to train the ID LoRA with clip feature. The perceiver resampler for ID LoRA is different from the one for base LoRA. We feed the crop region of face into the clip VIT and bypass the face encoder branch. During the training, we associate ID LoRA with some rare words, also known as trigger words, to reduce the impact on other meaningful concepts. We let the training target of each iteration randomly selected from the following cases. 1. If the text prompt contains trigger words, and both base LoRA and ID LoRA are enabled, it aims to reconstruct the target image. 2. If the text prompt does not contain trigger words, and only ID LoRA is enabled, the target is to align with the output of base model. 3. If the text prompt does not contain trigger words, and both base LoRA and ID LoRA are enabled, the target is to align with the output of base LoRA. The third stage is to train the ID LoRA with ID feature. Training with clip VIT feature facilitates fast convergence, but bring a strong structural constraints on face. Thus, we leverage the clip VIT feature only during early iterations, and then fix the clip branch and switch to ID embeddings for the subsequent training. Now, let's move on to the experiment session. Compared with previous methods, HyperLoRA gets rid of oversaturation and plastic faces, and generates highly detailed and photorealistic images. This slide presents more portrait images synthesized by HyperLoRA across various ID and scenes, demonstrating its generalization. Control net is a practical network to control the diffusion models with additional condition images. Thus, it is important for an ID plugin to be compatible with control net. This figure demonstrates HyperLoRA can also generate portrait images with high photorealism and fidelity when equipped with different control nets. We find HyperLoRA exhibits the similar properties as StyleGAN. For example, a concept slider LoRA can be created by the LoRAs generated from a pair of images. Feed a face image and an edge-edited version into HyperLoRA and subtract the generated LoRAs. We will get an edge slider LoRA. That's all. Thank you for watching. The code and model are available now. Please scan this QR code or click the links to access it.